So I'm going to make videos on substitution reactions. The substitution reactions can be classified into two types: electrophilic substitution and nucleophilic substitution. I have already made a couple of videos on electrophilic substitution reactions. If you haven't watched the videos, I give those links in the description section. Whenever you find time, you can watch those videos. So in this series, I am going to discuss nucleophilic substitution reaction. The nucleophilic substitution reaction can be classified into two major types, that is aliphatic nucleophilic substitution reaction. Another one is aromatic nucleophilic substitution reactions. So this aliphatic nucleophilic substitution reaction can be classified into three types. Number one is SN1 reaction, number two SN2 reaction, and number three SNI reaction. And whereas the aromatic nucleophilic substitution reaction can be classified into two types. Number one is SNAR reaction and number two benzene reaction. And in this video, I am going to discuss SN1 reaction. Shall we start? First, let us discuss what you mean by the term SN1. S stands for substitution, N stands for nucleophilic, and 1 stands for unimolecular. Okay, so with this basic idea, let us discuss this S1 reaction with a general example. I have given a general example here. So a tertiary alkyl halide is treated with water molecule, and this alkyl halide is getting converted into an alcohol and hydrogen halide. So in this case, water is used as a nucleophile. So this reaction is otherwise called as hydrolysis. Okay, so this S1 reaction can be otherwise called as hydrolysis. Suppose instead of water, if you use any general solvent, this reaction is called as solvolysis. So the other name for SN1 reaction is hydrolysis or solvolysis. Okay, so with this basic idea, let us discuss the mechanism of this SN1 reaction. And the mechanism involves two steps. The first step is the formation of carbocation. So what happens here, then leaving group, that is halogen atom from the tertiary alkyl halide, it is leaving as X minus. That means this halogen taking the electron from carbon atom and this is leaving as X minus. As a result, a carbocation intermediate is generated in the first step. So the first step is otherwise called as carbocation formation. And the second step is this carbocation reacts with the nucleophile water molecule. So water molecule lone pair is going and attacking the carbocation, and as a result it leads to the formation of alcohol, and this hydrogen of water molecule is leaving as H+. So this step can be otherwise called as alcohol formation. So in this SN1 reaction, the first step is formation of carbocation and the second step is formation of alcohol. Okay, so coming to the rate of the reaction. So in the first step, if you happen to look at that molecule, it is a neutral in nature. So this neutral species, that is alkyl halide neutral species, is becoming an ionic species, that is carbocation. Okay, so if you happen to check a general idea, which species is more stable? A neutral species is more stable or ionic species is more stable? And obviously a neutral species is more stable. And here a neutral species becoming an ionic species, that means a stable species becomes a less stable species. So this step is slow step. Okay, so in the second step, if you happen to look at here, and this ionic species becomes a neutral species, so that is a carbocation becomes an alcohol. So this step is fast step. Okay, so in kinetics you might have studied that is a slow step is always the rate determining step, and in this case the first step, that is a formation of carbocation, is a rate determining step. Okay, so with this information we can write the rate law of SN1 reaction. So you can check here, so that directly proportional, that is rate is directly proportional to the concentration of alkyl halide. So alkyl halide, in other words, you can also give the concentration of substrate. Okay, so if you check the rate law, there is only one molecule, that is alkyl halide, is present. So how it came? You can check the rate determining step, and the rate determining step is having only alkyl halide as a reactant. That is why this reaction is called as unimolecular reaction. Okay, and this rate is independent of the concentration of nucleophile. So there is no nucleophile involved in the rate determining step, and this SN1 reaction is independent of the nucleophilic concentration. Okay, so this is about the rate of the reaction. Now let us discuss that effect of substrate in SN1 reaction. For that purpose, I have given 4 molecules here. The first molecule is known as methyl chloride, the second molecule is called as ethyl chloride, and third molecule is called as isopropyl chloride, and fourth molecule is called as tertiary butyl chloride. Okay, so this is an example of methyl halide, and second species is an example of primary alkyl halide, and third species is known as an example of secondary alkyl halide, and the fourth species is an example of tertiary alkyl halide. Okay, so we need to know which is more reactive and which is less reactive in SN1 reaction. For that purpose, you need to look at this rate determining step. So you know that what is the rate determining step in the SN1 reaction? That is a formation of carbocation is a rate determining step in SN1 reaction. So you need to draw the carbocation intermediate of all the 4 species. So for example, in this case, the methyl chloride, this halogen is leaving as Cl minus. Okay, so as a result, a methyl cation intermediate is formed, and in this case, the primary alkyl halide, once the Cl minus is leaving, it leads to the formation of ethyl cation, and in this case, once the Cl minus is leaving, and this leads to the formation of isopropyl cation, and in the last case, once the Cl minus is leaving in the first step, and it leads to the formation of tertiary butyl cation. Okay, so this methyl cation is generally called as methyl cation, and this ethyl cation is an example of primary carbocation, and this isopropyl cation is an example of secondary carbocation, and this tertiary butyl cation is an example of tertiary cation. And I have already made videos on stability of carbocation. You can also check those videos, and I have already discussed that this among carbocation, tertiary butyl cation is the most stable, and followed by you have secondary cation, and followed by you have primary cation, and the least stable will be methyl cation. Okay, so what do you mean by the most stable intermediate? That means we know that the first step is already a slow step. Okay, so whatever the intermediate that is more stable, that will be formed very easily. Okay, please keep in mind, the more stable intermediate will be formed very easily. Okay, so once it is formed means the second step is already first step. Okay, so among all the 4 carbocation, that is a tertiary butyl cation is more stable intermediate. That means this tertiary butyl cation will be formed very easily, and this tertiary butyl alkyl halide will be the most reactive in SN1 reaction. And next one is secondary alkyl halide, and followed by primary alkyl halide, and the least reactive will be methyl halide, because the methyl cation is least stable. That means it will not form that easily. So that means first step will not form easily. Once the first step is not forming means the second step will not obviously react. Okay, so that means the least reactive will be methyl halide, and the most reactive will be tertiary alkyl halide. So this effect of substrate can be put up together in this rule. So that means when an electron donating group is attached to a carbocation means then the SN1 reactivity will be increasing. So that is what I have mentioned here. So when electron donating group increases, SN1 reactivity will be increasing. So that's it. So this is about the effect of substrate. Now let us discuss the effect of solvent in SN1 reaction. So polar protic solvents are suitable for SN1 reaction. What do you mean by polar protic solvent? Polar means charge separation should be there. Say for example, you have water molecule. You have hydrogen on oxygen atom. So among these two, which is more electronegative atom? Obviously oxygen atom is more electronegative. So oxygen carries del minus and hydrogen carries del plus. So whenever the charge separation is taking place in a molecule, then it is called as polar solvent. Okay, what do you mean by protic? Whenever the solvent is capable of giving H plus is known as protic solvent. So we know that water is getting splitted into H plus and OH minus, and it is capable of giving H plus. So that is called as protic solvent. Okay, so this polar protic solvent is used in SN1 reaction. What is the reason? And again you need to look at the rate determining step. And if you happen to look at the rate determining step, you have here a cation and anion, that is an ion pair is formed. So whatever solvent that you are using in this reaction, that solvent should be capable of stabilizing both the cation and as well as the anion. Okay, so for that, for example, I have given an example here. So you can check here, a tertiary cation is formed, and as also an anion is formed, that is X minus formed as an anion. Fine. So you have here positive charge, and we know that oxygen carries 2 lone pairs of electron. That means lone pair means it has a negative charge. So this cation is stabilized by this anionic part of water molecule. Also, you can look at this anion part, that is leaving group halide ion, you can look at here, and this halide ion is stabilized by partial positive charge of water molecule. Okay, so this both cation as well as anion is stabilized by water molecule. That is why you need to select a solvent that should be polar protic in nature. Fine. So this is about effect of solvents. And the last one, we have the stereochemistry. This is what very much important. For the purpose, I have taken a molecule here, and if you happen to look at the configuration of a molecule, the first priority goes to bromine, second priority goes to phenyl group, third priority goes to methyl group, and fourth priority goes to hydrogen atom. And this 1, 2, 3 groups arranged in clockwise direction, the configuration of molecule is R. And this compound is subjected to SN1 reaction. Once again, you need to look at the rate of the reaction. What is the rate of the reaction? So that is a formation of carbocation, that is a rate determining step. So that means here the Br minus is removed, that is bromide is removed. As a result, a carbocation is formed. And this carbocation is sp2 hybridized. What is the geometry of a carbocation? That is trigonal planar. And this carbocation occupies trigonal planar geometry. Okay, assume that this carbocation is present on the plane, trigonal plane. Okay, so the incoming nucleophile, that is a water molecule, can approach that carbocation from the top or from the bottom. Okay, the both possibilities are there, 50-50 ratio. So in the second step, you can check here, this water molecule lone pair can come and approach here. It can approach from the front side. Also, it can approach from the back side. Both possibilities are there. And the front side attack probability will be 50%, and back side attack probability will be 50%. And both attack is taking place 50-50 ratio. And as a result, you will get the two products here. 50% of this product and 50% of this product. And if you happen to look at the configuration of the product, the first product carries R configuration, and second product carries S configuration. So in SN1 reaction, if you take a chiral compound and if you treat with a solvent like water molecule or any other alcohol kind of solvent, you will end up with the formation of 50% of R or 50% of S. Okay. Otherwise, you can also call it as 50% of D isomer, that is dextroisomer, and 50% of levoisomer. And if you call it as a 50-50 ratio of R and S or D and L, it is known as racemic mixture. So in SN1 reaction, always a formation of racemic mixture will be obtained. So this can be given here, that is 50% of retention product. What do you mean by retention product? And if you happen to look at the configuration of reactant, that is R. And the first product formation configuration is R. So that means the reactant configuration is retained in the product configuration. This is known as retention of configuration. And if you happen to look at the other product, that is S configuration. So the reactant configuration is R and the product configuration is S. That means the opposite configuration has formed. So this is known as inversion of configuration. So that 50% of retention product and 50% of inversion product will be observed in SN1 reaction. So otherwise known as racemic mixture is formed. Okay, so this is about the basic level of SN1 reaction. And if you want to know the SN1 reaction stereochemistry in advanced level, always inversion product will be obtained more than the retention product. So that means inversion product will be slightly excess and the retention product will be slightly lower. So this phenomenon is known as partial racemization. So if you want to, if you are studying in a basic level of SN1 reaction, you can write it that in SN1 reaction always racemic mixture is formed. And if you are studying the SN1 reaction stereochemistry in slightly higher level, and always partial racemization will be formed. I am not going to explain the partial racemization in this video, and if you want to know more about the partial racemization concept, you just make a comment in the comment section so that I will make a new video on the partial racemization. So with this, that SN1 reaction is over. So guys, whatever the things I have discussed in this video about SN1 reaction is very much useful to you. If you find so, you can like the video, share your feedback in the comment section. Take care. Bye.